Imagine an object speeding through our solar system, not from our neighborhood, not from the distant edges of our planetary family, but from another star entirely. It's not just passing by quietly. It's leaving behind clues about where it came from and what secrets it carries. This object is known as Comet 3I/Atlas, and it's only the third confirmed visitor from interstellar space ever observed. But why does this matter? Because hidden in its icy core and fiery tail might be answers about the origins of our galaxy, how stars evolve, and even how planets form. Stay with me, because this is a story about discovery, mystery, and cosmic history. Every comet we normally study belongs to our solar system. They orbit the sun, influenced by its gravity, and come back time and again. But 3I/Atlas is different. Its orbit doesn't loop back. Instead, it's on a hyperbolic trajectory, meaning it came from far beyond and will eventually vanish back into the darkness of interstellar space. What makes this fascinating is how rare these events are. Only two interstellar objects had been detected before, one nicknamed ʻOumuamua and another comet called Borisov. Both stirred massive debates and excitement. Now, 3I/Atlas joins this exclusive club, offering a third chance to study material born around another star. This comet isn't just a chunk of ice and rock. It's a messenger from a completely different stellar environment. Its composition, speed, and brightness give scientists a way to peek into conditions that existed around stars billions of years ago. For us, that's like receiving a time capsule thrown across the galaxy. And while it may look like any other comet at first glance, its path tells us everything we need to know. It does not belong here. That realization alone makes it one of the most intriguing discoveries in modern astronomy. It forces us to rethink not only how common interstellar objects might be, but also what kind of secrets they carry as they travel between stars. So, why does 3I/Atlas stand out compared to other cosmic visitors? First, it's unusually fast. The speeds it reached confirm that no orbit within our solar system could have produced it. This object was born around a star far away and has traveled untold light years to arrive here. Second, its composition is like a fingerprint. By observing its brightness and the gases escaping from it, scientists can compare its makeup to comets in our own system. Differences in elements and isotopes could tell us whether stars in other regions form comets differently or perhaps not so differently at all. Third, 3I/Atlas belongs to a much older population of stars, sometimes referred to as the thick disk of our galaxy. That makes it even more intriguing. It may have formed billions of years ago, in conditions very different from those that gave birth to our sun and planets. This comet could literally carry frozen materials older than our solar system itself. Think of it as a fossil, but instead of being buried in rock, it's preserved in ice and space dust. If comets within our solar system already teach us so much about planetary birth, then a comet like this could expand that lesson to a galactic scale. It's like having a direct sample of another star system delivered to our cosmic doorstep. Now let's get to the big question. Why should anyone care about 3I/Atlas? The answer lies in perspective. Every interstellar object that crosses our path expands our understanding of the galaxy as a whole. Each one is evidence that planetary systems don't just create comets for themselves, they scatter them, and some wander into entirely new neighborhoods. Studying 3I/Atlas allows us to test how unique, or ordinary, our solar system really is. If its chemistry looks familiar, then maybe the processes that shaped Earth and the other planets aren't rare at all. If it's dramatically different, then we're learning just how diverse star systems can be. And there's another layer. Interstellar comets may carry the building blocks of life. If icy objects like these can travel across the galaxy, then the ingredients for biology itself might be far more widespread than we ever imagined. That idea alone fuels the age-old question, are we alone? This comet also challenges technology. Capturing meaningful data from such a fast-moving visitor is no easy feat yet. Every observation sharpens our ability to study future interstellar wanderers. In a way, 3I/Atlas is preparing us for discoveries still to come. So, its importance isn't just scientific, it's philosophical. It reminds us that our solar system is not isolated, but part of a much larger, interconnected galaxy where material freely travels from star to star. Comet 3I/Atlas isn't just a visitor, it's a storyteller. It carries within it the frozen whispers of a star system we may never see, offering us a chance to read a chapter of the galaxy's history that would otherwise be closed to us. What makes it so remarkable is not just its rarity, but its potential to answer enormous questions. How did stars and planets form in regions far from ours? Are the building blocks of life common across the galaxy? How connected are we, really, to other solar systems? We may never see this comet again once it slips back into the void, but the insights it leaves behind will echo for generations. Its fleeting presence reminds us that the universe is full of travelers, carrying secrets across unimaginable distances, waiting for us to notice, study, and wonder.